Y'all ready for this? Welcome back, my friends. Today we are talking about Tidyverse and data manipulation. So yeah, it would be really nice if all of our data sets came to us completely ready to analyze with no manipulation required. Yeah, that would be nice, but it never happens. So you might be getting your data set from Qualtrics or from a colleague or from an SQL database or something like that. And then you're going to need some sort of manipulations, like maybe you're going to need to filter the data set so you remove those observations that didn't meet the inclusion criteria. Or maybe you're going to create new variables like sum scores. Or maybe you want to take a massive data set that has like 100 different columns and only select those columns that you need, maybe like the 5 or 6 columns that you need. Or maybe you need to reverse code some items that had reverse scaling in it. Lots and lots of different reasons why we might need to manipulate our data. So that's what this and the next couple of videos are about, is how do you manipulate your data so it's ready to analyze. And what I'm going to introduce in this video is some elements of what is called the Tidyverse.
What is the Tidyverse?
So glad you asked, young bright student of mine. So the Tidyverse is a set of R packages written and developed by the same core people. And basically what they've done is they have completely kind of sort of rewritten R to make it easier to use and more intuitive. And all the packages in the Tidyverse share the same grammar or set of rules and the same philosophy guiding data analysis. And so the advantage of this is it's easier to use the Tidyverse. You're probably gonna make fewer mistakes when you use it, and it's easier to understand somebody else's code when they write in the Tidyverse. Chances are, if you are learning R from my videos, you will probably not see how amazing the Tidyverse is. Because I'm gonna teach you the Tidyverse from the beginning. It is only people like me who've been around for a while who know the old way, see the new way and say, wow, this is so much easier. And just trust me, it is. So with that, let's get into R. To begin, we're going to install the Tidyverse package, and to do that, you can just type in install.packages tidyverse. I'm not gonna do that because I already have it installed. And then once you have it installed, you can run line 22 and require it. So within Tidyverse, there are several packages, including ggplot2, which is what flexplot is based off of. But also there's something called dplyr, and the D in that stands for data frames, which you're familiar with data frames at this point. And plyr is to suggest the idea of pliers. And the basic idea behind dplyr is that it is used for data manipulation, just like you would use pliers to manipulate an object. And so within that, there are 5 core functions that we're gonna use. We're gonna use filter, select, arrange, summarize, and mutate. So let's review those real quick. So we'll start with filtering. Now earlier we used the traditional way of filtering. So you may remember this code from a couple videos ago. So we got laptop equals 854, books equals 321, etc. And then we combine those into a data frame. And then in one of our exercises, we wanted to ask R to show us the row with the laptop. And so to do that, we created a logical statement here. And basically this is saying, all right, out of all the items within, or out of all the entries of expenses, $ item. So if I brought that up, we got laptop, books, and clothes. We're asking it which row contains the value of laptop. And so it is saying true for the first one and then false, false. And so when we store that in an object and then we go expenses, laptop row, it'll just return the first row. So we already did that. That is filtering, by the way, but it requires a lot of steps. So instead we can use the Tidyverse version of filtering, which uses the function just called filtering, and it makes it quite a bit easier. So we're gonna use the filter function, and then the first argument is the data set that we're gonna use. In this case, that's expenses. And then the second argument is our logical statement. So in this case, we're saying item equals laptop. And remember, it's a double equals there. And it gives us the same result, but it does it more quickly. So let's do that again, but this time we're going to use the Avengers data set. So I'm gonna, because we need the Avengers data set, I'm gonna require flexplot because that's where the Avengers data set is stored. So now what we're gonna do is we're going to filter the Avengers data set, and we're going to have it return All rows where IQ is greater than 130 and injuries is greater than 3. And so if we run that, and if we inspect the output, and then go to IQ, notice all of these IQ values are higher than 130. And if we look at injuries, all of those injuries are greater than 3. So it is returning a data set that meets these conditions. And notice that I was able to just line them up together. So you could have as many as you want there. Maybe I could also do damage.resistance is greater than 1.9. And I'll give us a smaller row. And now we've got the extra condition on there. Now, I'm just filtering. I'm not saving those results to another object, but maybe you want to do a data analysis of the normal people who fought in the final Avengers battle. So you might go filter Avengers and then superpower equals yes, and then you can save that into a data set. Here would be normal people, and if we did head normal underscore people, we would see the first 6 rows of the data set, and notice that, where's our, oh, there it is. Superpower, oh, that was not, sorry, superpower equals yes. So these are not normal people, but all these have superpowers. And yeah, just a quick hint here, if you go superpower equal yes, that is correct. But if you do just a single equal, it will have a problem. And let's see what what happens when we do that. So I just copied that and pasted it. And so it gives you an error. And fortunately, the Tidyverse is also pretty informative with the errors. It says input.1 is named. This usually means that you have used equal instead of double equals. Did you mean superpower equal yes? In that case, we did. And by the way, you assign things. So I could create a new variable called superpower equals yes. And that creates in R's memory an object called yes, or an object called superpower, and its value is yes. But if I say double equal, it is asking a question. Is superpower equal to yes? And in that case, it is true because I just created that. So let's do some more complex comparisons. So we can filter the Avengers dataset, and we could ask it to return results where shots taken is greater than 400, or, that's what that vertical pipe means, minutes fighting is greater than 60. And so if I look at this, let's look at shots taken. Where is that? There it is. So I'm saying, give me values where shots taken are greater than 400. Well, none of these are greater than 400. That's because nobody met that criteria. So that must mean that all these have minutes fighting greater than 60, and that is the case. So there's something you might want to remember is how to do an or statement. You can also do an and. So in this case, we are looking for individuals where they have taken more than 400 shots and they have fought more than 60 minutes. And I'm actually going to change that because that wasn't doing anything before. So let's do shots taken greater than 100 and minutes fighting is greater than 60. And so in this case, all minutes fighting should be greater than 60, and they are. And all shots taken should be greater than 100, and they are. So that's pretty cool. We are learning to filter like champions. And then now we can do another one. So in this case, I'm doing shots taken is greater than or equal to 200. And actually, I'm going to do 100. I think as I was writing this, I didn't realize that nobody had taken more than like 150 shots or whatever. So I'm going to do greater than 100 and superpower is not equal to yes. And that gives me a data set with 642 rows. And I'm not going to look at all that, obviously. But, so we've talked about the or, we've talked about the and, we've talked about the greater than or equal to. And also, and here's another thing that we're introducing is not equal to yes. So you can do superpower is not equal to yes. Or you might be able to do superpower is not equal to no. Or you could, or you could equivalently say superpower is equal to no, but that's only because in this case we only have 2 superpowers. So maybe if you had a data set where you had superheroes, non-superheroes, and then technological superheroes like Iron Man, people who don't have superpowers, but their technology gives them superpowers. And so if you have 3, you might say, I want to get rid of anybody who's not normal. Or so you might say superpower not equal to no, or something like that. And then it'll give you both the superheroes and the technological superheroes. So Another sort of operation that might be helpful for you is to use the in. So in basically tells R to find every instance that meets whatever conditions I'm giving you. So let's say we wanted to look at the expenses data set. Now remember, that has 3 items, laptop, book, and clothes. But let's say we want to return those rows that have either laptop or clothes. And in that case, you can use the in operator. And so if we were to just run this part of it, oh, never mind, it won't work. And I know why, and I'm not gonna tell you why, because it's too complicated right now, not until the next video. But basically what that will do is it will find every instance that has either laptop or clothes. So that's filtering. Very, very useful if you're manipulating data set, like if you have an exclusion criteria, or if you have some sort of outliers you want to get rid of, you can use the filter to exclude those outliers. So another situation where you might need dplyr in the Tidyverse is through arranging data. So this is basically for sorting data sets, and it takes 2 arguments just like filter does, or 2 or more arguments. So the first argument is the data set, and the second argument is the variable that you want to filter on. And so in this case, I'm going to filter on injuries, and then if I go head data set and then look at injuries, which is, where is it? Oh, there it is. It gives me zeros. Now let's say you're like, hey, I wanted it sorted from largest to smallest, not from smallest to largest. Well, a very simple way to change that is to use the desc, which is short for descending. So if I ran that line and then did that again, it would give me injuries descending. Now one thing I don't have up here, and I'll go ahead and add this. Let's say you want to sort on multiple columns. Well, you can actually do that. So I can sort on injuries, but of course there's gonna be a lot of ties in there. And so maybe the next thing I wanna sort on is north and south. So I might go north _ south. And if I do that, and then head sorted injuries, then we see that injuries is still sorted, but now the order of north and south has changed. So we have all the north first. And if we were to do, by the way, I don't know if I ever told you you could do this. You could do n equals 20 instead of n equals 10. And then, so now we've got, oh, I guess there are more north than I thought there were. More people in the north battlefield who had 5 injuries. But if we were to go far enough, we would eventually see that go from north to south. So that's arranging data. You can use the descending to sort in descending order, and you could also include multiple columns to sort your data set. Very handy. Now let's talk about another important function, which is selecting. So very often you end up with a crap ton of variables. When I worked as a biostatistician, this happened all the time. They measured something in there, or they got blood from participants and then measured like 1,000 different variables based on their blood sample, and then gave you a data set with 1,000 or more variables. Well, when you're doing data analysis, it's kind of cumbersome to have to deal with all 1,000 of those variables. So sometimes it's nice to be able to select just the variables that you need, and we're gonna use the select command to do that. And so maybe we want to create a new data set called new _ Avengers, and we're going to, and just like the other Tidyverse commands, it's going to require 2 or more arguments. The first is the data set, and then second is all the columns that you want to select separated by a comma. So in this case, I'm asking it to give me the Avengers data set, but only the IQ, agility, and speed columns. And if I ran that and then looked at head for new Avengers, I would see that it just gave me those 3 columns, which is exactly what I wanted. Now another way to do it that is shorter is, let's just actually look at head Avengers. Let's say you know that the variables you want are gonna be the first 3 columns, or maybe the first 5 columns or whatever. Let's say you just know that they're in a sequence. You can save some time by putting a colon between them. And so what this will do is it will say, give me all the columns between IQ and speed, which in this case is just 3, but maybe I wanted to go from IQ to super power. And so if I did that, and notice the parentheses here, that's important. Oh, oops, I'm jumping ahead, superpower. So that's going to give me all the columns from IQ to superpower, and that's exactly what I get. And now I can go down to this. You can also have it return everything but particular columns. So you might say, give me all the columns but IQ through superpower. And to do that, you got to put a parentheses around the sequence of variables you're trying to select and then a negative sign in front of that. So if I ran line 82 and then 83, now it returns a data set with everything but the variables from IQ to superpower. So that's very handy. Now, let me go ahead and do some special conditions of what I want to select. In the link in the description, I have included a link to a file called mindfulness. This is just a data set that I made up, but I'm going to go ahead and read it in. Make sure that you save it to your R project folder if you're following along. And then if I'm going to just look at the data set, notice I've got mind 1, mind 2, mind 3, and I simulated this to be as if you had 5 Likert scale sort of items about mindfulness, 6 stress items, and then 7 depression items, as well as age and gender. Very common in psychological research to have this, as well as like marketing research and that sort of thing. And let's say you want to create a data set where you are looking at just the mindfulness variables. Well, you can use additional function with the select function to specify more unique conditions. So in this case, I am using select to select from the dataset D, but now I'm asking it to select all items that have the word mind in it. And so if I ran that and then looked at head, notice that all of my columns that are returned are just those columns with the word mind in it. So that's a very handy way if you need to create a new data set that is just a subset where they all share the same name. Now I could also do that for any item that has, so that was starts with. You could also say anything that ends with the number 3. So maybe for some reason you want to find any variable that has the number, or that ends with the number 3. If I do that, then it gives me the 3rd item of mindfulness, the 3rd item of stress, and the 3rd item of depression. So that's very handy. Now sometimes the way your naming convention is, it doesn't start with mind or doesn't end with mind or whatever. It doesn't start or end with it, but it does contain it. So if I were to look at head D, notice all my depression items, the beginning is different for each of the items. And I just kind of made up a fake way of doing this. But here you have A, B, C, D, and E appended to the beginning of depression. And so now what I want is I know depression or DEP is going to be in there somewhere. And so I can have the select function return all those items that have the words DEP in there. And then if I looked at that, it would give me just the DEP items. Now it's very important when you're doing this, any of these, that you double check and make sure that it came out as you thought. So maybe, for example, if you did DE instead of DEP and did that and then assumed this was all the depression items, what you might end up with is something like this, where you have gender, because there's a DE in there. And so you might be doing an analysis under the assumption that all these are depression items, but one of them, just because of the way it was named, happens to be selected too. So you don't want that. So again, just be careful with those. So that is selecting data. And again, so let me just review what we've talked about. So filtering is to eliminate rows from the data set. Like if you're trying to get rid of missing values, or if you're trying to get rid of people who don't fit the inclusion criteria. Arranging is for sorting the data set, and selecting is for selecting columns in the data set. So the difference between filter and select is very small but important. So filtering eliminates rows, select eliminates columns. And now we get into a new one, probably the most helpful, I think, and that is mutate. So mutate is used to create new columns that are functions of existing columns. So let's say we wanted to create a new variable called hours fighting. And so hours fighting is just going to be minutes fighting divided by 60. And so to do that, I might decide I'm going to create a new object from this one. The first argument is going to be the data set, as all these functions so far have been. And then the second argument, I'll go ahead and put this on a new line, is the first part. It's basically going to be an assignment of some sort. So you're going to name the variable here. So I'm telling it I want to create a new variable called hours fighting, and it is equal to, and then however you're going to create that. So in this case, I'm telling it to take the minutes fighting variable and divide it by 60. And so if I do that and then do head, notice that I've got a new column called hours fighting, and that 0.12833 is just 134. Nope, sorry, I'm looking at the wrong one. Minutes fighting, where are you? Oh, there it is. 7.7 minutes divided by 60, and you'll get 0.128 hours. So that's helpful. So, but just like some of the other ones, you can include additional arguments. So instead of creating one variable, you might create two variables. So maybe eventually the whole hours fighting is really just kind of to get me to a place where I can compute kills per hour. So how many people they killed within an hour's time. And so in this case, I'm creating two new variables. One is hours fighting, which is equal to minutes fighting divided by 60. And then the second one is kills per hour, which is kills divided by that variable that I just created. And by the way, that's one of the cool things about Mutate, is whatever variable you create, you can use it for later mutation options. And so if I run that bit of code, now I've got my two new columns, hours fighting and then kills per hour. One common way that you might need to use Mutate is to do a sum score. So I'm going to read in the mindfulness data set again. And then maybe what I will do is say mutate D. And then this time I'm going to say mindfulness is equal to mind1 plus mind2 plus mind3 plus mind4 plus mind5. And if I do that, that will create my sum score of mindfulness, which is 20 for the first person, 35 for the second, etc. Now there is a faster way to do this that's actually a little bit complicated, but I'll go ahead and walk you through it. So we can do mutate D. The first part is the same, but now we're gonna include another line. So mindfulness equals, so we still create it the same way. But now what we're gonna do is we're going to do a more complex function, which is row sums. So here we're saying sum up the rows, and then we're going to combine it with a select statement. So basically this select right here, actually I'll go ahead and show you what that looks like. Oops, I forgot to include the close parentheses. That is going to return a data set that just has the mind variables. And you've already seen me do that earlier just with the Avengers data set. So I'm using what we learned about select. And now what I'm going to do is I'm going to compute the row sums on that. And so it's going to do 4 plus 3 plus 4 plus 4 plus 5 for the first person, 8 plus 7 plus 7 plus 7 plus 6 for the second person, etc. And if I do that, and then if I go head D2, now I get the exact same result as I got before, but it just saves me the effort of having to type out each of those mindfulness items. So that is a brief summary on using Mutate. Again, Mutate is for creating new variables. The last one we're going to talk about is the summarize function. So summarize is similar to Mutate. What Mutate will do is it will create a new column that is some function of the existing columns or something like that. With summarize, we're going to sum across the rows. So like, let's say you wanted to do a demographics table or something like that. We can use summarize to do that. And you can spell it either the American way with a Z, or you can spell it the non-American way with an S. Either way, it's going to work the same. And how you use it is the same way as the other functions, is that your first argument is the data set. And then the second argument, we're going to do very much like we did with Mutate. We're going to create a variable and then specify equal and then specify exactly how you're going to compute that. So in this case, I'm saying I'm going to create a new variable called mindful mean, and that is equal to the mean of mindfulness. Now remember, this is going to sum across all the rows. So that is the average mean across all variables. So that's kind of cool. Now, just like with Mutate, you can do multiple calculations. So you can create a mean and a standard deviation, for example. And that will return an object with the mean and the standard deviation. But this doesn't look like a demographics table, does it? So let's say we wanted to do it for each of the groups. So within this data set, we have a variable called gender. And so let's say we want to summarize by gender. So the mean for the male, the mean for the females, and the mean for the non-binary individuals. And so to do that, it's going to require 2 steps. One is that we create a new data set called grouped D2. Well, you can name it whatever you want. I just took my D2 data set and then just changed it to grouped. And so in the back end, what that's doing is that is telling R that there is a group in there for males, females, and non-binaries. And then now what I can do is I can take that data set and then I can create a mindful mean, which is the mean of mindfulness, and then an age mean, which is the mean of age, but it is going to do it by group. So if I run that result, now I get a table where I have the 3 different genders listed, and then I have the different means for the different variables. And of course, if I wanted to, I could go stress underscore mean equals mean of stress. Actually, that's not gonna work because I haven't created a sum scale for stress yet. But if you had done that, that would work. But you get the idea. So with that, let's review our learning objectives. Number 1, the Tidyverse way versus the R way of doing things. And I didn't give you much information, just know that there are 2 ways of doing it. The R's way is a little more complicated, more prone to error. Tidyverse, I guess the important part is that it was built by the same people with the same set of rules, the same philosophy of data analysis, and so there's consistency. Number 2, know what filter, arrange, select, mutate, and summarize do. Again, filter eliminates rows from the data set. Select eliminates columns from the data set. Arrange will sort your data set. Mutate will create new columns. And summarize will aggregate across rows in a data set. Number 3, selecting a range of columns. So remember, if we want to select a range of columns, we just put the colon in there when we are using the select statement. Also remember how to select everything but a range of columns, and remember to do that. We put the negative sign in front of it and then parentheses around the range that we are specifying. Also understand the auxiliary functions: starts with, ends with, contains, group by, and desc or descending. And then finally understand how to do comparisons, like using an and symbol, a vertical pipe, double equals, not equals, and the percent in percent. So that is my conclusion on the dplyr basics. In the next video, I'm going to talk about the pipe operator and how it will simplify your life immensely. So with that, see you next time.